we'll just activate the Facebook stream, then we'll be on our way. Someone needs to write me a script to automate all these steps.
So you want one button to control them all?
Yeah, there are 10 things I need to happen. I just have to do a little research to get more efficient at it.
Now that you're learning Python, Ken, that might be the tool that helps you.
Yeah.
Sounds like you gave Stephanie the night off.
That's right. Yeah, she usually does Copilot here. You're almost there. Just don't want people to miss the very beginning of that, John, because they say, what did I miss? What did I miss? And I can't answer all that, so. Okay, welcome. Good morning, good afternoon, good evening to everybody. Just do a quick audio check to make sure we're good. All right. Welcome to the Propeller 2 live forum today. We have a wonderful topic from a favorite presenter of mine, JonnyMac, John McPhalen, the Tao of Spin2 programming. Before we introduce John formally and let him loose, just a little bit of housekeeping like I love to do. Won't be able to sell you much this time, which you know is my favorite thing to do. First off, if you're like me, any project you've done has probably involved code from JonnyMac. And my list of projects is so long, and the only reason I was able to get them all done is because I had help from JonnyMac. So I just pasted a link in here, and if you want to be like me, go over here and make a deposit in JonnyMac's bank, tax-free. So he'll appreciate that. It's very important. I'll be taking an offering for John again before this is over. Thanks, John, for tolerating that. Next up, as y'all know, teachers are very important to Parallax, and education is a company mission of ours. Right now, one of our partners, cyber.org, who's funded by Department of Homeland Security, is giving out Parallax robots en masse. If you know an educator in a tech education program, this is the real deal. I'm pasting the link into the chat right now. Forward that to them. This is a great way to get things in class that students want to learn right now. I mean, after all, what do you remember from high school? The shop class, like me? All right. Next week, we're aiming to have these in stock. So our long list of 22 clipboards has been ordered now, and they'll be arriving in about a week. And we'll be producing objects. I say will be, but I kind of know where the objects come from. They end up coming from JonnyMac and hopefully a few others. Oh, this shouldn't have been here. This is a secret. Oh, just kidding. I see Bob Lawrence is already snapping pictures of the screen, but here's something we're working on. And I wish I could just sell you these and see orders coming in, but this is a P2 Edge. It looks like a microbit. It's just using the connector. And this is something we're working on right now. And this is, the idea here is move all the expensive parts to the 4-layer board and make these and allow them to be integrated into products that are made. This is a bare bones P2 module. Okay, so it's got a SPI flash 16 megabyte, in parentheses it says 128 megabyte, a 1.8 volt 2 amp switching power supply, a 3.3 volt 300 milliamp LDO per 8 IOs, 20 megahertz crystal oscillator, 2 LEDs, which are buffered on pins 56, 57, all IOs, power reset, etc., broken out to the 80-way edge pad, all right, where you can connect 5 volt and ground. So any input or thoughts on this, let us know. We want to really, don't know the cost yet, Colin, sorry. Want to push these things out at some point. We want them to be used in products. If you have input about it, we'd like to hear that. Here's the size. That version does not have a USB connector on it, but I think we might be making 2 of these so that people can just hook it up, say like on an airplane and start coding if we ever fly on airplanes again. Cost, just as low as we can make it. As many as you can buy would help. And here's an example of a breakout using that connector. With this one has a USB port underneath, and also you'll see the same pins that are on the P2 eval board. Timeline soon, as soon as possible. We found a wonderful new partner in Taiwan that produces our boards in 3 days that we actually really like. So we'll be speeding things. Also, objects added this week. 2 of them. One is from Eric Smith. It's a Spin2 object you can call from C. So this is really cool. Take a look. I just read up on it. And then JonnyMac added full duplex serial also within the last week. This is something we've really been needing. And it's on the GitHub, posting a link in right now. So as we know, this is the early adopter series, and things are often difficult until they get easy. Like I can't do much programming until a lot of this gets developed and I see more examples. And I think a lot of people out there are probably like me too. So thanks you guys. It's looking great. And then Chip, briefly, are you here? Okay, we might come back to Chip.
I'm right here.
All right, what's this about? The tarantula.
Oh, okay. So there was a bug that had been in the compiler since E34I where I had added in some like automatic constant resolving, and it was not accepting indexes. So it wasn't really the compiler per se that was blowing up, but it was the constant resolver that was causing this problem. Anyway, I fixed the bug and posted a new version, 34X. So you can download that, and it should work fine now. I'm surprised this was never detected through all those versions.
Cool.
But it's fine now.
Good fix, Chip. Now, leading up to JonnyMac, I was just thinking about John last night, and I don't want to use any time to talk about all the things he does because he's going to do it so well, but he has a huge history. Going back with Parallax at least 23, 24 years. This is one piece of that history called Stampworks, a kit we made. It was very popular back before all the little accessories were super, super cheap on China. A lot of people bought this from us. It had a really cool board that John designed. There's a video of it on our website on Parallax's YouTube. So I'll paste links into that later. John also wrote numerous columns and is still writing for Nuts and Bolts. We produced 7 books. This is about 2 feet thick of printed material. And the majority of these columns are from John. They were started by Scott Edwards, but here's one. You could see our whole history here. Like this was from basic stamp stuff. And then we had the SXB compiler with Terry Hitt. And then the Propeller. So John has been with Parallax for a long time. All these columns are available for download now. Perhaps one of the most important projects I worked with John is the DEF CON badge. Not just 22, but DEF CON 24. And when you're making a product like this, and quite honestly, we made 17,000 of these. There was a lot of money involved, massive manufacturing, hundreds of thousands of dollars. You have to rely on people that really know what they're doing because this code at this convention had to work perfectly. And I never once had concern that it would not work. And JonnyMac delivered it timely, completely, and it was awesome. So, and many of the projects I've worked on, like here's a GPS data logger John and I did back in the day on RC airplanes. A lot of fun. Just fly it around, get the data, get it out of the basic stamp. Things have really progressed. And even some of the recent just afternoon hacks I've done, I cannot get away from having JonnyMac code. It's there. This is come and get your meat. I butchered it myself. So how
Come and get your meat. I butchered it myself.
the WAV file playback and the WS2812s. A little bit of Ozzy Osbourne. Can you hear that, by the way? Okay, sorry. Hope no one loses sleep. Stuff like this, reading a tachometer off of a alternator and managing motors. That's a hybrid robot. More DEF CON badges, a visual metronome. I mean, even though I didn't talk to John about this project, it used his weight count blocks in Blockly. So he is everywhere with his code. And I created this not for my son, who already knows how to get by musically, but for myself, because I'm helpless. So, and just one quick note, so we won't come back to this. Next week, we got a good presentation from Jeff and Michael. And if I haven't mentioned JonnyMac, who always works for free, open source needn't be totally free. We can also pay for it, and I really want us to do that. So I encourage you to do like I just did and go over here and make a deposit in the bank of JonnyMac, tax-free. He earns it, deserves it, 10 times whatever we give him. And live from Hollywood, California, I present to you JonnyMac. John, I hope all that enthusiasm wasn't too much for you.
You know, I'm a professional actor. We were trained to absorb the love. Anyway, thank you very much, Ken. It is kind of funny how long we have been doing this. So let's just jump right in, because I have a ton of stuff, and I think you guys will see me as just my screen. So that's what I look like. You can see me on screen. Notice the picture that we used. That was my professional acting picture. If you want to know who the most popular people are in Hollywood, it's not actors, it's makeup artists. They make everybody look good. So, anyway, I'm going to go to my presentation.
And people are welcome to stop and just ask a question too. It can be hard just to talk to a PowerPoint and keep chatting without dialogue. So make yourself at home or use the chat, just unmute.
I got ahead of myself. So can you see my PowerPoint, Ken?
Perfect.
Okay, here we go. This is a bit of a joke, but it's JonnyMac's Tao of PowerPoint. The Tao is an ancient Chinese system, means the way. I'm not suggesting that this is the way. This is my way. This is how I do things. That's why I subtitled it, "What would JonnyMac do?" As if anybody's actually ever going to ask that. Just a little bit of background. I am a unicorn in the entertainment world. Not the unfamous part, but I'm actually from here. I was born right outside of downtown Los Angeles. I have formal electronics training from the Air Force, where I worked on electronic countermeasures, that's radar jamming, and then radar systems. As a kid, I wanted to earn a patent. That was a goal, and I have 3 now, 2 for a sprinkler timer and 1, believe it or not, for a water intake for a pumping system that I helped with. I'm just a part of a team, but I came up with an idea that I thought was ridiculous, and that what turned out to be patentable. I am a member of SAG-AFTRA, which means I get paid for acting from time to time. Ken talked about my writing exploits. This is on the technical side, all the stuff for nuts and bolts. I have a column online now about the P2. Stampworks was one of my first projects for Parallax that I still refer to and others do, and it was quite nice. And as Ken pointed out, I have been with Parallax, using Parallax microcontrollers since 1994. If you read the online story, the quick version is I became aware of Parallax microcontrollers in 1993, but I didn't believe the ads. And I found myself having to take some time off work to heal from a surgery. So I ordered a basic Stamp 1 kit, and the day that I opened it up, I started playing, and I didn't stop for about 24 hours. And that kind of started my relationship with Parallax. I do use Parallax products, not just for play, but for commercial products. So these are some of the things that I have done along the way. My first commercial product was a product called Hotwire for a company called Flotronics in Dallas. Now, that's a stupid name for an alarm product, but I couldn't talk the marketing department out of it. And they were mad when they couldn't get the website for Hotwire because the travel site had been started and got there first, but had not been announced. So anyway, that used a basic stamp and a lot of really tricky coding to keep the main program loop running at a consistent rate so we could do accurate timing. One of the things that I'll talk about with the propeller is to do accurate timing is very, very simple. Just after, in around 2006-ish, a guy named John started a company called EFX Tech to make controllers for the Halloween world and movie props and that. And he asked me to design and code those for him. So he has a lot of customers like Disneyland and Legoland and, you know, escape rooms and those kind of things. And I use those. In fact, this is one of his boards called an HC8 that I use quite a lot in my Hollywood projects. Designed for a company called Rocky Research. Trying to find it, I thought I had it on my desk. Oh, here it is. A big, the green screen's killing me. This is a HVAC controller for a big university project. That was a little involved, but we got it because it has CAN networking and Modbus networking and lots of sensors. But that project, in the end, as difficult as it was to start, turned out really, really well. If you drive down the road, you see those big signs, you know, with the arrows that go kunk, 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 kunk. Those are called arrow boards. And now there's a company making them with propellers in the sign itself and in the cab display that's there. One of my bigger clients is Elite Laser Tag. They make lots and lots of laser tag guns and games, and they're all propeller powered now. Another one of my long-term and fun clients is Johnny Jib. There used to be another company called Camera Turret, and we make motion control stuff. Right now we're dealing with a project to control targets on a shooting range, and to allow the user to be able to animate those targets and then play back a sequence. And so that's got motor controls and, you know, joysticks and speed controls and lots of stuff like that. I do lots of specialty work for prop builders in movies and TV. Well, I've got a couple of pictures to show about that. And it's usually what'll happen is a prop maker will call and say, hey, I need a driver for this part, or can you write a little bit of code to do this, or can you make me this board? So it's all kind of specialty stuff. And then my friend Steve Wang, who some of you may know, he's a major league creature creator here in Hollywood. His company makes big trade show displays. So let me show you these things. So here's a real Hollywood project that's propeller powered. This character is called Lightning, or sorry, Thunder from the TV show Black Lightning. This belt buckle, it looks like it's just shiny, but it actually lights up and is animated. And the first version of this belt buckle had lots of problems and broke down on set. So I got a call from my friend Rick Gallinson, who some of you may know as the paintball minigun guy. You know, he's got a propeller-powered paintball minigun. And he said, hey, I've got an emergency, I need your help. And we did this very quickly. He took the old belt buckle, made a 3D model, sent me an outline of that. So then I overnight made this circuit board, sent it off, got it back a couple of days later. We soldered up. This is obviously a 3D model, but we started with a model so that we could fit everything together because we only had one shot. We couldn't take a chance on it not getting right. The TV show it had a very short hiatus, and we had to get this costume back to Atlanta and working before the show restarted. Anyway, did a 3D model, did that. This worked out so well and so quickly, they asked us to replace the controller, which originally was an Arduino Mini, so we replaced it with a Prop Mini. Sorry, this picture is not very well focused, but we were in a bit of a rush. We didn't have time to send out for a circuit board, so over here you can see I just hand etched stuff at home. We had to build 3 working versions. And over here, these connections go to a wireless DMX receiver, and then these go to APA 102C LEDs. Those are like WS2812s, but they use 2 wires. And they're preferred in the movie and TV business because they have a higher PWM frequency. Anyway, this went into the backpack. Rick put it all together, sent it off to Atlanta, and everybody was happy as a clam. And we even gave them extra features, and the behavior was nicer. Everything worked out really, really well. And that was one of these typical Hollywood run with your hair on fire and get it out the door because you've got a lot of expensive people waiting on set. And we did it. So that was on the small side of things. Here's a very big thing. I don't know how many of you are gamers, but if you ever played League of Legends, you may have seen these characters. They're very popular in the game. This is Annie, and this is Tibbers, the bear. They are two of the more popular. So Tibbers from here to here is about 8 feet tall. And this whole display, believe it or not, is controlled by one propeller. What we did, we sat down to analyze the requirements for this. Obviously, there's a lot of high power LEDs in this thing. And what we decided to do was use a propeller as a DMX controller. And as we get in more about spin programming, what I did was I organized it so I had a DMX transmitter operating. That's where the HC8 comes in handy because it has a RS-45 on it. So it just loaded up a DMX driver. And then 6 processors running each for one processor for each tree. You can see there are 4, it's hard to see, but there are 4 trees. There's Tibbers and there's Annie. So each of those elements on the display ran their own program. And this is a little bit of work, but is so much easier in the end because the boss, who is this guy right here, this is Steve Wang. So those of you that are monster movie lovers, this guy became really famous in Hollywood for creating the Predator. You may have seen that, you know, Arnold Schwarzenegger and that crazy monster. So Steve and this gentleman back here, who sadly is in heaven now, Matt, they sculpted the Predator and then Steve painted it, and that launched Steve's career. But he's very fussy. And when we were creating this thing, he said, okay, John, I just want to see the back tree. So turn off everything else and let me see what the back tree is doing. The nice thing about the propeller and being able to divide animations into separate cogs is I could do that. I just didn't turn on the other animations, so they were dark. And we fine-tuned every single tree individually. We fine-tuned Tibbers individually and Annie individually, and then brought it all up. The best part of this thing, and I wanted to show this picture because for those of you who walk out of the movie theater before all the credits have gone by, these are the people you're ignoring. So these are my friends. These are the tech artists that do so much hard work in the business. And this thing here, this display took about 15 weeks for this team to fully put together. My part of it was actually fairly easy. I had probably a week in the shop to do all of the electrics and the programming and that.
John, are the smoke effects propeller controlled?
No, they are not. They just let them run. And in fact, that's not even smoke. This is an interesting thing. The venues where we do displays will not allow us to use theatrical fog, which is good anyway. Anybody who's been around that stuff knows it's very hard on the throat. So this is the shop supervisor here, and he and I do all the electric stuff. So I will put together the plan. He'll rough out all the electric work. I will come in and work with them to finalize everything and then write the code. And for you Buffy the Vampire Slayer fans, this guy played the demon that got trapped in a book and then sucked into the computer and then turned into the robot demon in season 1 of Buffy the Vampire Slayer. He did that. But he's a very good guy, very smart, crafty guy. And he found those ultrasonic misters for nurseries to keep the air moist. And that's what this is. So this is actually water vapor coming out because it doesn't generate smoke, but it looks really great, especially with the lighting effects and the throbbing LEDs, and it looked really nice. So on this day when we were taking pictures, the marketing manager for Riot Games came over and she walked through this door over here and came around the front and saw the display and just burst into tears. And, you know, everybody started clapping. And that's the kind of thing. All of these people, including this goofy guy right here, we're all artists. We love art, and we do things to move people. You know, we're storytellers, and that's all. It's the human side of things is what we do. So that was a really, really great day for this entire team. I love working with these people. They're all fun and smart and crazy. And as you can see, the shop is animal friendly. All right. Here we go. So I should say this. Everything that I say, this full disclaimer, protecting my friends at Parallax, this is my opinion. Parallax is not responsible for anything I have to say, and they don't. And I understand when they don't agree with me. These are my opinions. It's how I approach things. Okay. No matter what I'm doing, if it's a simple demo or, you know, I have 2 clients that I'm working with right now, the key to winning is knowing what you want before you get there. I mean, you don't jump into an Uber and not tell them where to go or give them really loose instructions, like take me to the garment district. For me to get in an Uber and go to the garment district, you know, it's about 12 miles away down in LA. That's easy, but what are they gonna do? Drive around until I spot the building where I'm gonna go? So know where you wanna go. And so, you know, your specification is kind of like GPS. And this is a phrase I say to my clients all the time. The root word of specification is specific. What you'll see, I occasionally will answer posts in the forums where somebody will say, well, it needs to operate for a short amount of time. No microcontroller knows what a short amount of time is. You have to specify a time in milliseconds or whatever the timing unit is. So be specific. Getting going, you know, it's not hard, any of this. I mean, again, I'm a professional actor. If I can do this, anybody can do this. And it just takes a couple of things, like being comfortable with some fundamentals. And that's going to be easy numbers and understanding some simple stuff in number theory and basic logic. Because that's all programming is using logic, and we're dealing with numbers. It helps, I find, if you like to learn things, because there's no project that you're going to do. If it's a blinky light or one of those giant displays like Annie and Tibbers, you're going to learn something. And if you enjoy learning, it just makes the task easier. And you know, long days don't feel so long when you love learning new things, even if they were accidents. That is part of the joy of the process, is discovering those accidents and doing something fun with them. So getting to numbers. This is where my friend, if he's still online, I don't see him there, Ryan will tell you, he's heard this story from me lots and lots of times. So numbers, getting comfortable with them. We always start with decimal because we all know this. We've been doing it forever. It's in our muscle memory and we don't even have to think about decimal. But if we do think about decimal numbers for a few minutes, then understanding the other number systems becomes far easier. So decimal comes from the base word deci, which comes from Latin decimus, which means 10. Why do we use 10? Well, most of us have 10 things here. Captain Hook uses base 6 numbering, but most of the rest of us use base 10. Okay. Each of these things, these counter things, we call digits. When we're putting them down on paper, we're going to use little symbols, these things here. These are the ones we use. These come from Arabic symbols, but so these aren't numbers. These are symbols for a value. And yes, 0 is a value. So in our lives and in programming, decimal is the default system. So when you're writing a piece of computer code, and it really doesn't matter the language, unless there's somebody doing something I don't know, if you write out a number, the compiler and anybody reading the code is going to assume it's a decimal number unless you indicate otherwise. So here's the stuff that you know internally, but I want to show you something to think about. So with decimal, so that when you look at the other number systems that you might not know, it makes it easier. We only have 10 digits in our base 10 system. So when we run past 9, we have to add another column, and then we'll use those 10 digits here. This column, the rightmost column, my right, your right's over there, is called the least significant digit. And that column, no matter the numbering system or the base, or what the fancy word for that is, radix, is always 1. That column has a base value of 1. So you can say 1 times whatever the digit in the column, that's the value of that column. So every number you see, the rightmost column, the least significant digit, that column value is always 1. The column to the right, to the left of that, the next one to the left, its base value is the base of the system you're working in. So in decimal, that would be 10. So this second from the right column is always 10. Every subsequent column is going to be the column to the right times the base. So we have 1, 10, 100. If we had more columns, it would be 1,000, 10,000, 100,000, etc. It's very simple. We don't think about it in decimal because we've been doing it our whole lives. But I'm asking you, if you're not comfortable with binary and hex and the other systems we're going to use, to think about it for a minute, because it will make understanding those systems easier. So in computers now, getting to other systems, we have two states, off and on. So we're going to use a 2-based system called binary. And again, they represent the states off and on. In the propeller, we use a percentage sign at the beginning of a group of ones and zeros to tell the compiler and other programmers, hey, this is binary. So if I see 1010 unadorned, that's 1010. If I see 10, or if I see percent 1011, that's binary 11. So that indicator is important. We need to remember that. If you're a newcomer to this stuff or need a review, memorize 0 to 15 decimal in binary. You can do it in a few minutes. It's not hard to do. And just remember, write it down, have a pencil and paper, do it longhand for a minute, but you don't need to memorize 32-bit values. That would be probably impossible, not worth your time anyway. Just memorize the first 15. So here, just as a review, is how we deconstruct that. Remember, least significant digit column always has a column value of 1. So 1 times whatever the digit is. The next column, moving to the left, always is the value of the base of the system. Our base in binary is 2, so that's going to be 2. Everything else is multiplied by the base. So it's 1, 2, 4, 8, 16, 32, 64, 128, 256, 512, et cetera, et cetera. Okay, and if you just remember 1 and then multiply by the base going left, you can manually figure anything out very quickly. Okay, so get really comfortable with binary. My friend Ryan, who is online, I don't know if any of my other friends from Aventador are online, but they'll tell you that when we would do our programming exercises and I would talk about this, the next day I would come in and just shout out to the office to one of my colleagues, okay, tell me what decimal 12, what is it in binary, what is it in hex? And just we quizzed ourselves on, so we got very, very comfortable with those numbers because we were an IT company and the binary and hex values came into our jobs all the time. In the propeller, there is another number system called Quarternary that uses 2 binary bits per digit. So it's it can be used as a shortcut for digits. So it's base 4, which means it uses the digits 0 through 3. We adorn a quaternary number with %%. I've heard Chip, I think, and a couple others sometimes refer to quaternary as double binary. I prefer quaternary because quarter is a fourth, but understand that that's base 4. I've not used it a lot, but looking back in some code in the P1, you'll see it. It's convenient to use for pixels for video. So you've got 0, 1, 2, and 3 can represent the colors off red and green. Oh, sorry, off red, green, and blue. I did one project one time for Disneyland. They were creating a hand stamp, stamp the kids' hands with the autograph of Buzz Lightyear. And so they were using my wave player, so they had a propeller already in there, and they wanted to light it up, but they wanted to have it just a little bit more sophisticated than on and off. And they only had 8 outputs, so that worked out perfectly. Because they were used to making table-driven lighting displays anyway. And so for each section of the animation, we had a long that was expressed as a quaternary, and then they could have 4 light levels if you include off as a level. So 0 would have been off, 1 is 33%, 2 is 67%, and 3 was 100%. So it just gave a little bit more interest to these little blinky lights, and it turned into a very successful product, and they made a bunch of them and deployed them to all the Disney properties. So if you take your kids to a Disney property and they get a Buzz Lightyear hand stamp, it's got a propeller in it. Okay. Octal is another number system that is not part of the propeller. I'm going to ask Chip if maybe we ought to put it in. It is convenient at times. And the reason that I bring it up is a couple of months ago, Ken asked me to write some code for the Pixie Cam. And the Pixie Cam has a return value for multicolored blocks, and it comes back as octal. So I had to put into my P1, then P1, I have it in P2 as well, number formatting octal output. And so octal uses 3 binary bits. So again, it's kind of a shortcut for binary. It's been around for a long time because in the 60s and 70s, a byte was 6 bits. And so instead of writing out 6 bits for a byte, you could use 2 octal digits to shorten it. And so back when computers were either had 6-bit words or 12-bit words or 18-bit words, octal was very popular, and it was built into Unix. Linux has it. So for you Linux people that are using the change mode command, those 3 digits are octal. They represent 3 bits for the different read, write, and execute permissions for each of the 3 groups. So it's around, and I have it in my formatting stuff for full duplex serial because of the Pixie Cam. Okay, hex is the other big one that we get used in programming all the time. It uses 4 bits, and since it's base 6T, this is an interesting thing. We have the Arabic numerals 0 through 9 that we use in decimal and the other systems that don't go that high. But now we've run out of characters, so we elect to use characters A through F for the values, decimal values 10 through 15. So if somebody asks you to count to 15, freak them out and say, okay, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. And when they wonder what's going on, you say, I just counted to 15 in hexadecimal. So in hex, we use a $sign to tell the compiler and humans, hey, this is a hex value. So if you're new, memorize A through F. And so, it doesn't take long to do these things, and I promise that you will be happy about it later, because everything that we're doing with a microcontroller is dealing with numbers, not only internally, but going in and out, because our ports we treat them like variables. Okay, oops. So here is a table that, has all of those in it. This is, you had enough information already to create this table on your own. And just to show you, we can do this with the propeller as well. Yeah, so if I, so the propeller, this is, I'll scroll down to the code. This is, I told it to.
Don't forget to Alt-Tab, just in case you're trying to show another app.
Okay, no, can you see my programming screen in PST?
Nope, we're still looking at the slide.
Oh, I'm looking at my editor. I did use Alt-Tab.
Oh, funny. Maybe not funny.
Doggone it.
Go down and share again.
It says you are sharing your screen. So I say new screen. I'll just go.
It worked when we tested it.
Yeah.
There we go.
Can you see my screen now?
Beautiful.
Can you see Propeller Tool?
PST, no.
I just brought PST up.
So let's see, since it's a different app, you might need to share the
doggone it.
display.
Why did this work before?
Yeah, it did, I know.
We thought, oh, we've got it. Okay, well, I don't want to get trapped here, but and I'll make this little demo available, but this bit of code, if you can see it, I'm looping through those values, and then I'm formatting the output in decimal, binary, quaternary, octal, and hexadecimal. So what you would see on PST is I'm gonna change my share back to the slide.
Could you show us the PST output, John?
Oh yeah, sure. I guess I just have to have it share PST, right?
Yeah, not everyone will have seen this here.
Okay. Is it
There we
showing
go.
now?
Yeah.
Okay, so this is the PST output from that. I recently added, I'd come across some code that was unidentified, and it did this numeric formatting stuff. And then I think I used that, and then I noticed Eric Smith also has formatting stuff kind of like this in its compilers, and it's very useful, especially if you've come from C or Python that has that stuff. So I've added to my versions of full duplex serial. But these are the number systems that we just talked about. Again, understanding that the Propeller does not know Octal. So we can use that as an output, as again with the case with the PixieCam, but it's not an internal system. The other ones are binary, quaternary, and hex, and obviously decimal. They're all systems that a Propeller understands. Okay. All right, are we back to the slide?
Yeah, we are. Thanks,
Okay.
John.
Sure. So we'll move on. So the numbers we just talked about, again, get comfortable with numbers. And then really the other part is logic. A computer program, as I used to talk with my friend Cliff, he was, in his final years, he was sadly suffering from cancer. And the thing about him is that he said, hey, as long as my brain still works, I'm going to ask you questions, Mr. McPhalen. So we used to have these great chats. I would ask him about acting and writing and directing, and he would ask me about technology. And he would always say, explain to me what a program is. And I would usually say to him, it's a series of written instructions that involve decision paths. Well, decisions are based on fundamental bits of logic. The primary ones are and, or, and not. And technically, you can take these three. These are the schematic symbols for the actual gates. With these three fundamental gates, you can build a computer. In fact, a friend of mine and Ken's and the Parallax team, Ryan Clark, he has a Twitch stream on Tuesdays called Transistor Tuesdays. And we started some months ago with these gates, and we have built a 4-bit processor from the gates up. And, you know, I know a 4-bit processor doesn't sound terribly impressive, but it was a really good learning system. And I'm looking across the wall, 2 patent plaques for a sprinkler timer that I created for Toro that used a 4-bit processor. So they are alive in the world and get used for very low cost devices. You'll also see and, or, and not as keywords in the language. There's another one called XOR. Now the XOR gate can be derived from these. And very quickly, and I always joke, should have been called all, because if you look at the inputs here, A and B are the inputs, Y is the output. We're going to use the digital signals of a computer. We're going to say, you know, 0 means false and 1 means true, or off and on, etc. So if you look at an AND gate, in order for the output to be on, both of these inputs or all of these inputs need to be on. So this truth table here shows you that status. If A and B are both 0, Y is 0. If B and A are different, still off. If they're both 1, they're on. So again, it's this and this, but I always think of it as all. If all of the inputs are on, then the output are going to be on. Or is similar, although we often refer to this as inclusive or, because as humans, we say this or that. We mean one or the other. This particular or here is this or that or both. So you'll see that in the output. If either A or B is active, then Y is active. And not is just an inverter. So, and in fact, in electronics, we call this symbol an inverter. So 0 becomes 1, 1 becomes 0. Exclusive OR works like OR, with the exception that it's one or the other, or but not both. It's how my uncle taught me. So exclusive OR is one or the other, but not both. And that's the exclusive OR. This you'll see as you get into your, for those of you who are new, that get into your programming later, this is very handy for flipping just a few bits in a large number. We use it all the time for that kind of thing. But I'm talking about circuits here, but we also use this as logic. And so when we're doing ones and zeros and from a circuit level, we call that bitwise logic. But we have, I don't know what you call it, logical logic. So here's a logical version. If it's hot outside and I own a pool, I can go swimming. So if it's hot outside and I own a pool, that's the logic. So the hot outside means I had to do some kind of test. So we could define that better by saying, if the temperature is greater than 80 degrees and the pool is open, I can go for a swim. So that's, gee whiz, somebody chime in and tell me what's, I want to call it logic, but it's not bitwise logic, it's just logic. Getting comfortable with this is the key to programming, because computers take inputs, do something with it, and do outputs. In fact, back in the early days, we used to say IPO, input, processing, output. The processing is decisions that we make based on logic. And I better really speed this up. So we'll get into the propeller stuff. Ken and I are talking about this after the announcement. So we want to be inclusive of P1 and P2 because the propeller is now a family. So these are some of the coarse, attributes of the P1 and P2. 100 megahertz versus 3, 8 cogs. This is a biggie here. It is 16 times more hub RAM. Hub is the shared area. I'll show you a graphic here in a minute. The cogs that actually run code, there's more space in the P2. Chip added a neat trick to the P2 that allows the cog to grab code right out of the shared space, which essentially gives you an infinite sized program. A lot more IO pins. The P2 has some analog capabilities, and we have these really neat bits of circuitry on the pins called smart pins that allow us to do complex functions. I'm gonna show a couple of demos on that. Couple of things. One of the things I do find myself when I'm out talking about the propeller is correcting bad information. I was having a chat with a guy who called me about writing code for Star Trek props, which I thought was going to be really cool because I'm old enough to have seen Star Trek when it was first on television. And he knew I was a propeller guy, and he said, look, I know you like the propeller, but we're going to use a PIC on this. I said, okay, fine. It's taken a step back, but okay, you're the boss. And he said, well, the propeller is just an 8-bit processor. And I said, no, it's not. It's a 32-bit processor. There's 8 of them. And that statement turned into a 4-hour conversation. He just didn't know. I think people hear 8 cogs and somehow that gets screwed up into 8 bits. And unfortunately, that project never happened because a young actor was accidentally killed. So the series, stopped. And but he, we've had lots of really interesting conversations. So the propeller has 8 32-bit processors that can all be running simultaneously, despite what the technical editor at Nuts and Bolts thinks. What they get shared with is each cog is connected to power, so reset and power in the system, the IO groups, and a really cool piece of tech called the system counter. This is a register that updates itself on every clock tick. It's immensely useful. The cogs run assembly. So the code that I write, and I'm an unabashed spin programmer. There's lots of other great tools for the propeller. Have at them. I use spin. I love spin. That's all I've ever used for my clients. They're all happy about it. I find a way to get done what I need to get done. It works really, really well for what I'm doing. The cogs are smallish, and so they have round robin access. Whoops, keep to this shared area called the hub. That's that big chunk of RAM. And they can, when they have their turn, the hub gives everybody a turn and share, and they can either send information to the hub or grab information from the hub. Now, Chip, I need you to chime in on this because I meant to call you about this. This is true, right? In the P2, adjacent cogs can do a sharing process. Is that not right?
Right. They can read and write each other's lookup table memory.
Okay. Okay. That's what I thought.
512 long. So yeah, they can talk back and forth through the memory.
Excellent. Okay, good. And also in the P2, as I talked about, we call it hub exec. The P2 can pull code right out of the hub. And this was inspired, was it not, Chip, by Bill Henning's LMM that he created for the P1?
Well, maybe. I mean, there was a lot of effort to try to bring code in externally and run it.
Yeah.
But, you know, I think the idea, at least for me, was just to make it so that cogs could have a super high-speed data conduit between them.
Yeah. Yeah, because in the P1, for those that are new to the Propeller, the P1 has a 2K cog limit. So, you know, you can do quite a lot, especially since the efficiency of the Propeller, but really big programs could be a problem. So a Canadian guy named Bill Henning created a thing called large memory model, where in effect was an assembly language interpreter in a way. That's probably a bad way to put it, but a little tiny snippet of assembly in a cog would grab assembly code from the hub and execute it. Now there was a speed penalty for that, not the case in the P2, but the LMM allowed assembly programs to grow bigger, and I think compiler vendors were using it, and it is a thing in the P1. The P2 does lots of neat stuff with memory and shuttling things around really quickly, and the hub exec is one of those things. So here's a very simple model. You've probably seen graphics similar to this, where you've got the 8 cogs, all of which could be running at the same time. They don't have to be, but they could be. They all have access to I/O pins, which we care about, and to the system counter. On any given hub cycle, a cog may not need to talk to the hub, so fine, nothing happens. It could, though, want this, say this cog wants to write information to a shared location in the hub. So let's say this was a sensor cog reading some kind of sensor, and it put it at a known location in the hub that then this cog also knows that location and can pick it up. So this is the basic mechanism in the P1 and probably most P2 programs for sharing information from cog to cog is using this shared space. So what we do as programmers is this program, when we start it, we say, put your information here. When we start this program, we say, get your information from here. It's the same spot. And since there's only one cog at a time has access to the hub, there's no data collisions. Now, if we need to send a big chunk of data before, you know, say this guy gets it, there are lock mechanisms. So this guy, for example, could say, hey, I'm going to write a whole bunch of data, so I'm going to set this lock. This guy will check the lock before it attempts to do a read. So it says, okay, look, you know, so consider the lock a kind of flag that says, look, don't mess with that until I tell you to mess with it. So there's nice little communications mechanisms, but it's all very nice. On that Star Trek guy, I think I was telling the story earlier, he made these really nice little pick boards, and we were talking about the project, and if those of you have seen the J.J. Abrams Star Treks, there was a Khan played by Cumberbatch, Benedict Cumberbatch, yeah, I think that's his name. Anyway, in the prison cell, in the back of the prison cell, if you go back and look, there's a giant kind of homage to 2001: A Space Odyssey. It looks like a giant HAL 9000 eyeball on the back of the prison cell. And that required 3 or 4 of these little pick boards. And he told me, he said, yeah, that was really crazy, you know, connecting wires and trying to get them all to cooperate. And I joked with them, I said, so you don't have a problem with multi-core, you just want to do it the hard way. And that, you know, got a laugh and helped him be a little bit more open to the idea of having a multi-core propeller chip where we have 8 32-bit processors that can work cooperatively together. As I said, going back to the Annie and Tibbers things, there was a DMX transmitter that was just blasting out data to the DMX bricks that ran the LEDs, and 6 cogs. So I had 6 cogs running animations, and then the DMX driver. And they all were working independently, but when everybody was turned on, it was this beautiful, beautiful display that now sits in the lobby of the company who bought it. All right, the Propeller Tool. If we're gonna write propeller code now.
Hey, Sean.
Go ahead.
You know what? So we should say something about, can you go back to the prior slide? So the P1 had 1 connector to each cog from the hub. Well, it was a single connector out from the hub that rotated to the cogs, right?
Mm-hmm.
So to make a drawing like this for the P2, what you would do is you would put an arrow with a thick section out to every single cog. So there would, instead of 1 arrow on this drawing, there would be 8, right?
Oh.
And
okay.
then every clock, that thing rotates so that every cog can get access to, well, the way it works is, let's say in this case, we have 8 cogs, right? So there are physically separate memories for every long address that ends in the 3 bits pattern of 0, 1, 2, 3, 4, 5, 6, 7. So what happens is, as that thing rotates and all 8 connectors are switching around, every cog has access to the next memory location each time, but they're each offset by 1 long. Okay. So this is how it's possible for every cog to read and write a 32-bit value, like streaming in and out of the hub memory continuously.
Oh, nice. Okay.
It's not having to wait for one thing to come around. It actually waits for like the address of interest to come around, and then it starts streaming data out, or it starts picking data up.
Okay. Yeah, this is the P1 model. I'm trying to keep this a global presentation, but thank you. And what we'll do, Chip, we'll talk about that after. Since I have this drawing, we can update it so it's available for presentation materials, because I've got some stuff that I'd like to put that in.
Yeah, and so basically we have, like, from the perspective of a cog, we have about 8 times the memory bandwidth that we used to have.
Well, you can see it in the performance. I think I said in one of the other streams, I took a P1 and a P2, ran them at the same speed and ran the same generic spin code, and the P2 runs 15 times faster, 16 times faster rather. It's a marked difference.
At the same clock frequency.
At the same clock frequency. They were both set to 80 megahertz. Yes. Yeah.
Okay, so also we're actually not 8 times the bandwidth, we're actually 16, because it took 2 clocks for that thing to rotate positions on P1. And on P2, there are 8 of those spokes, and they click to the next position on each clock. Right.
Yeah, you can see it. I mean, the performance difference. I mean, you know, I'm obviously I like the P1. I'm going to do lots and lots of stuff with it, but it's almost, I shake my head and smile a lot how quick the P2 is for lots and lots of processes. That doesn't mean I don't want things faster, which we're going to talk about. So now, Chip mentioned he released a new version of Propeller Tool today. And sorry, phone was ringing. Old Parallax friend Ryan Clark just tried to call me. Peanut is Chip's development section where he's doing stuff. So we have access to it and we can use it. But Propeller Tool is the official tool, if you will. And it's you know, it's got lots of niceties built in that I particularly like. Those, you know, it is a tiny bit of a joke, and I don't mind being the butt of that joke, that I'm really fussy about formatting code, formatting presentations. It's because of this town over here is brutal on people that are messy with presentations. And so I learned that lesson when I was 18, when I got excoriated by a famous actor for having 2 typos in a script. And I just became a lunatic about formatting from that point forward. Anyway, the Propeller Tool is what you want to use. Now, it is a Windows-only tool for the moment. I'm going to keep nudging my friends at Parallax to go cross-platform, and they'll get there. But it does run. Rick, we mentioned earlier, he runs it on a Mac through an emulator. And probably lots of people in the stream do. My friends at Disneyland, they use Macs. It works fine. I'm probably the same thing in Linux. I have a Windows laptop with emulators for Linux in it, but it seems silly to try to put it into Linux and put a Windows emulator in a Linux emulation, so I didn't bother, but I'm sure it works. Just one thing about Propeller Tool, whenever you use it, keep doing that. Don't let it install to the default folder. These quotes around special are sarcastic quotes. Microsoft, they do crazy stuff sometimes. The x86 folder is protected. They don't want you messing with it manually, which creates a big problem for the library folder, which gets installed as a subfolder of the application. So when you're installing the Propeller Tool, it will allow you to put it anywhere you want, and it runs fine. I've never had any trouble running it outside of the x86 folder. So put it somewhere else. That way you can get to the library folder. So if, like in my case, I want to just grab all my library files and send them off to somebody, it's very easy. I have asked Jeff, and he said it's on the list, and he's going to consider adding a feature to Propeller Tool down the line where you can bundle up all of the files in your library so that you can send them out to somebody. Ken, were you trying to get my attention? Okay.
No.
Okay. So if you're going to use the P2 version, so you need to install version 1.32 first. So remember, don't install it in default location. Grab the alpha, it's on the Parallax downloads page, unzip it and just copy it into the folder. You'll have to manually create a shortcut. And since I redid it so I could create some graphics for this display, I had to manually associate Spin2 files with it, but the first time it didn't seem to do that. So you may have to do that. You may have to do manual association, but it's pretty easy. And then you can do P1 and P2 code in the one environment. So here's the installer. So when you get to this point, see where it says it wants to put it in the x86? Don't do that. Click the change button. Change this down here. I happen to have a folder on my system at the root called My Programs. Excuse me. I stick it in there. I've got other Propeller software or Parallax software rather. It works fine. Verify it here and then do that. Once you're good to go, then just copy the program in and you'll be set. I need to mute myself for a second, Ken.
Yep, get something to drink. No rush, John.
I know that looks like a can of beer, but it's actually water. Okay. So, getting going. Again, I'm an inattentive nut when it comes to program formatting. Everybody that knows me knows this. So one of the things that is great about Propeller Tool, both versions, is that you can start with a template. So since the P1 and P2 are different, there are different templates. You can specify different templates for the P1 and P2. Whether you use my template or somebody else's template, there's lots of good ones out there. Start with a template. It'll just make your life easier. You'll be organized. You have a framework that you start with that is consistent, and that will make your life go easier. In my case, when I start a project, I will then outline the project with empty methods. Then plug in the code one at a time. Now, sometimes you'll need method A to test method B. And let's say method A is a sensor reading. Well, just put a value to send back, so spoof the behavior of one while you're testing the other. Again, I'm a little nutty about this. I make sure that a method works individually before I move on to the next, because then I can lock in, I don't have to mess with it. And, if you do as I have in the past, and we've all done, you just do a whole bunch of coding and then say, all right, let's test this, and it breaks, it becomes problematic because one thing can lead to another. It's just, this seems slow, and sometimes it is, but you end up with working code. And for my clients, they're always very happy. They never seem to get worried about, as long as we're meeting, the deadlines we all agreed on, they don't expect even a simple project that, there isn't a process to it. So again, Keep your code neat and tidy. Document as you go. As humans, and being an actor is a part of, we pay attention to humans, and we model human behaviors. A human thing that I'm guilty of just as much as anybody else is, that's easy, I'll do it later. If it's easy, just do it right now. Get it out of the way, including the commenting, because you're in the moment. Get the commenting done, make it nice and orderly, and then you don't have to think about it later. Or, what happens is people say, I'll do that later. That never happens. It's like, I got to get this out the door. It goes, there's no documentation. I'm facing that right now on a client project, and I'll show you some hideous code that I have to deal with right this second.
John, where can somebody get your template? We will put it into the Propeller Tool.
I'll send them.
I'll
send it to you. I don't know that I have it out publicly. Occasionally people in the forums will say, where do I start? And I'll send it to them. But it's out there. But I have new P1 and P2 templates. Wonderful. And I'll show that in a second. But test. Don't surprise people with non-working code. All right, so this is where my anal retentive nature really kicks in. This is my style, not in, this is, do it the way you want. This is how I do things. Constants are always in uppercase. So I know when I'm looking at something, if it's in uppercase, that's a value that cannot change. And if it's got 2 words in it, I put an underscore. And this is not of my creation. Other languages, people do this. These are standards from other languages that I've adopted for Spin. Variables, I should have put, variables are in lowercase or camel case. Increasingly, I'm using camel case because I'm getting bigger programs and they need more variables, so I'm using camel case a little more frequently. You know what I didn't have on this list is keywords. So Spin keywords are all lowercase too. I'll add that before I send you the presentation. And so constants in uppercase, keywords always in lowercase. I don't want to be fussing around with pressing the shift key and all that jazz. Just do it lowercase. It's easier on the eyes too. Predefined values that you put into a DAT section. So these are kind of interesting. I don't know what to call them. Well, we do call them predefined values because they behave like constants unless the program changes them. So they're like malleable constants. So for that, I should have talked about, but anyway, I use Pascal case there. So I'll know where that comes from. I do have exceptions. I am human. I break my own rules. For variables, if my variable is actually a pointer to something, I will add a P underscore to the beginning. That tells me that's a pointer. For new people, a pointer is the address of something. And same thing with strings that I might predefine in a data table. I will put an S underscore in front of whatever the name is. So I know, okay, that's a string. And I should never be doing anything, mostly anything with this, unless it's associated with strings, like using a string function or comp string or one of those kind of things. I use 2 indents on spacing. People that come from Python like 4 sometimes. Some C programmers also like 4. It's funny, in those languages, I tolerate that, but in Spin, I can't. I have to have 2 spacing, otherwise it makes me crazy. And one of the other really nice features that Jeff built into Propeller Tool is smart tabs by section. Well, we're going to talk about that in a second, but the Spin program is broken up into sections, and the tab settings are unique per section, which makes it really, really nice from a tool. In fact, when I am working with other editors, I often find myself saying, gosh, I wish this would work like Propeller Tool. Keep in mind that you can help yourself with, having to write out a bunch of comments if you just pick really good names for your constants and your variables. The program becomes self-documenting. Now there's cases like, for doing a simple loop, we'll use a single letter. But if it's something a little more sophisticated, we should give it an actual name, and that way we can minimize our comments for the line or for the section. And, remember, programming is a team sport. And my friend Rick, who I've mentioned earlier, he will say to me, nobody's going to see this code. I said, 2 years from now, when you open that back up, you're going to wish you had made that neater and you commented it better. And it's human. I know, because I've run into that same thing. I look at code and think, what were you thinking, John? Come on. Now, on one side of that, don't be too clever. Sometimes we do that, and then later we're thinking, what was that? So be clear, but this is actual code from a perfectly working XB object that I wrote that somebody else decided to modify. And since this person is not online and not a regular in the Propeller community, I'm gonna tell this joke. He claims to have worked for Microsoft. When I saw this, I thought, no wonder Microsoft is updating Windows every 2 minutes, because if this is what they're doing, it must be hell to keep track of programs. These constants will not, in fact, you can't use this in Propeller Tool. He had to use BST to compile the code because these constant names were so long. In fact, in his trashing of my beautiful object, he has a line of code that is 250 characters long. And it's even if you have a 4K monitor, it's ridiculous. You shouldn't have to move your head right to left, or left to right rather, to read a line of code. The Python people will appreciate that because, the PEP 8 standard says 80 characters and leave it at that. I try to keep it around that too. All right. In my code, remember we talked about the structure of things. This is the way you'll find all of my programs laid out. I have a header, so you know who's guilty. I put the timing stuff at the top. I follow that by the IO pins, and this I actually do in 2 sections. I do the fixed IO pins, which don't change. So on the P1, that's going to be pin 31, which is the programming and debugging RX, and pin 30, which is debugging programming TX, and then 29, 28 are the I2C bus. Those you can use for other things in application, but I consider them fixed IO pins, so I identify them that way. On the P2, we have 63 and 62 rather for the serial, and then the next 4 for the flash and the SD card. After that, everything else is available. Although in my code, I'm tending to kind of protect pins 56 and 57. And if my projects need an I2C bus, that's where I'm putting it, is on those 2 pins. Oops. Then I lay out my general application constants, objects, variables, predefined data. This is for small stuff that oftentimes I write code for people that can't code like I do, but they can make adjustments to what I've written. So I will use the predefined section to give them things that they can tweak without having to get into the code. And then all of the, our objects, our methods rather. Just a note too, we have public and private methods available in the top object, which is what the parallax speak for, that I prefer to call the application. Public and private is irrelevant. Within a file, the file, any method can call any other method. Now, if we have a child situation where this guy is using things from here, only the public methods from the child are available to the parent. This is why I like Spin. It's very small. It's really simple. And if we had 8 hours, I could make everybody who isn't presently a master. I promise. It's that easy. It is a really clean, elegant language. It's like C. C is very small. And that's why C became very popular. Spin is very small. And we have some basic core stuff, and then we develop libraries to handle the other stuff. Now, Spin, for those that are new to it, is an interpreted language. So for those that maybe come from the IT world or are familiar with Java, it's kind of like that, where Java gets compiled to these things called bytecodes, and then the bytecode interpreter pulls them apart and executes the code for the platform. You could call the Spin interpreter the Spin, bytecode engine. So the downside is it is slower than native compiled codes. If you take a Spin program and run it through Propeller Tool and download it and measure the speed, which you can't do in the Propeller, it'll run at whatever the speed X. If you take that same code and compile it, say with FlexSpin from Eric Smith, it'll run faster because he's compiling it to native code. Now, the other side of that is with the bytecodes, you can have much, much more code density. The laser tag project that I talked about, the main application was 8,000 lines of spin code. There was a lot to it. In fact, it was so big, we ended up then breaking it up into other parts. And you know, so if the user did a certain thing, we could actually read another part of the program from an SD card, load it in, reboot, and run that part of the program for configuring the weapons or loading up a referee gun. One of the things that I do like it is that it uses indenting to define program blocks. None of this nonsense with curly braces or beginner end or any of that nonsense. It also doesn't need semicolons at the end of the line. It doesn't need a colon at the end of a loop line, which that makes me nutty about Python as much as I do like Python. It's very clean. It's super easy. It does borrow elements from Python, C, and Pascal. Python, the indenting, mostly from C operators, Pascal, some operators, in particular the assignment operator. When you're going to assign a variable, use colon equals, which I think comes from Pascal. It does have some quirky operators you got to get used to, especially the P1, but you know, we're humans. We just get used to things and we say, okay, that's the way we do it. And it is loosely object-oriented. And what I mean by that, I talked a minute ago about having one file as a child operative to the other. We call them the objects. In traditional object-oriented languages, we have things called inheritance, where if I have a function in the child, I automatically have access to it in the parent. That's not the case. For example, a real-world one that I did recently is I took my I2C object and I created an I2C LCD object from that. Well, there's functions inside the general I2C object that I wanted in the LCD object. I had to make a call to it. So for example, in my I2C object, I have a function called present, which just tells me if that device is on the bus. So if I want to do lcd.present inside LCD, I have to make a call to I2C.present. So it doesn't have automatic inheritance, but otherwise the object orientation stuff is somewhat similar to other languages. This is one of those kind of things that catch people out. There is a slow motion train wreck in the forums right now where the person won't accept this. In Spin, whatever the first method is, runs. The compiler doesn't care what you call it, but whatever is first in your top object, that's what runs. I, by convention, call that main, like C programmers do. But what happens, I've seen, is that C programmers will sometimes stick main, what they think is going to run first, down at the end of their listing. Don't do that. Whatever you want to run, put it at the very top. So you see that here. I use that. There's slight syntactical differences between Spin1 and Spin2, but otherwise that's the same. And this is something that I think I may have liberated from Ray Roddick. I noticed in one of his objects, and if it wasn't you, Ray, I apologize. Sometimes you're doing an object that you don't want it to run as a standalone. So for any of those things, especially if it's going to be dealing with hardware, I put an empty method called null at the beginning, so that if I accidentally say download when I have the object window open, it won't hurt anything. It just stops. Again, not my idea. I saw it, I liked it, and now I use it in all of my stuff. Another thing that is part of those fundamentals, when you're calling methods, it's like a go sub with an automatic return. I've seen this a couple of times, not recently, but it's worth pointing out. I saw somebody said they started with their top object, and then they called the next, and then they called the next, and then they called the next, and then they went back to the top. And they said, hey, my program runs for about a minute, and then it blows up. And what they didn't realize was that when they called one method, it wanted to jump back. So they just should have put a list at the top, and I'll show that in code. In the P1, every method always returns a long, whether you use it or not. So most of the time it's going to be 0. But if you change the result value to a value, it'll go back. One of the neat things about the P2 is that you can return multiple values. And I have a section on this in my online article for those that are interested in that. There is also a way in the P2 to ignore one or more of multiple returns if you don't need them all. This is key, this stuff right here. One of the nice things about Spin is it's really simple. All the control uses two things. You do loops with repeat, that's it. And your conditional stuff is if, and else if, and else, and case. That's it. All the control is in those statements. And so it's very small and very elegant, but you can do super powerful things because of that simplicity. Okay. One of the things that I like most about the Propeller, and now I'm certainly, not a great assembly programmer. I tried in the early days. In fact, that's why the basic stamp appealed to me, because I was trying PICs and, what am I trying to think? Motorola, like 6811s and those kind of things. But getting into the assembly and cycle counting and all that nonsense, and it just was a pain in the neck. In the Propeller, as I showed in that diagram, there's this system counter that automatically iterates with every clock cycle, and every cog has access to it. And you can take a snapshot of it and then wait for it to be at a value, and you get a precise window. You don't have to go through and count cycles anymore to get precision timing. This is one of the most understood things by people who don't use a Propeller. Every time I get into a conversation with another programmer, they say, geez, I'm having trouble. I need to run this at a very precise interval and counting. You don't have to count cycles. And you can, but even in assembly, you can do this stuff. So this is one of my favorite things that Chip put into the Propeller, is this counter that you can use for timing, because it allows you to do very precise things. There was a discussion just a couple of days ago on the forums about doing a quasi-ladder logic, like a PLC kind of thing. And in my experience with ladder logic, they want the rungs of the ladders to run at a very specific interval. You can make that happen. In fact, let me do this. I probably have to do share again. So I'm gonna go to the editor. I'm gonna show a real world program from a commercial product where I use the counter.
John, I don't know how I would have done the metronome without weight count being in Berkeley. Yeah,
exactly. Yeah, and it just for everything. So let me. I need to. It's actually in my P1 folder, but I can get there easily from here. Oh. So I'm opening up some P1 source code, but well, here we go. So this is an EFX Tech product called the FC4, which is a light fader. In every one of the EFX Tech products that I did, can everybody see my editor?
Yep.
Okay. Down at the bottom, I might have been lying about it being in this one. Darn it. I'm sorry. This was not a planned. So.
That's okay. We're learning a lot, and there's no time limitation on learning.
Okay, so here's a template for the HC8 that I talked about, that I use a lot. This is my template for it. So since we're talking about this, just show you that what I preach, I use. Here's my header. This is an unusual thing. This particular board had some changes in it with I/O that were affected by the revision. So I created a PC revision constant on there so that I could deal with the setup. Here is my timing stuff. I think I also liberated this from Ray Roddick. Here are my I/O pins. Now in this case, I define with the I/O pins for the board. Again, here's those fixed pins I talked about for the P1. And then Oh, since this is a template, I don't have anything in there, but you would often see if somebody said, hey, make me a program using the HC8, what I would often do is then come in here and say app IO. And then I would define my application IO pins as a function of these. Since this, since the HC8 hardware is established, I don't want to mess with the names of the code. But I'll show you something that I do and I do this in most programs. Now, let me do this here. This is a nice feature. There we go. I have this background thing that launches into its own cog. So for the folks that are new to the Propeller, you can start up another spin interpreter into any cog. I do it all the time. In this particular case, this is just doing some background management. And in my case, the HC8 has on it an RGB LED, and then it has a bunch of inputs over here that are processed through 2 shift registers. So I start this background, and here's the key to this neat timing in the Propeller. Right here, I'm taking a snapshot of the system counter. And now I'm going to wait at the top of this loop for that time plus 1 millisecond. This is a system constant that was defined up at the top. So what will happen then is once this happens and I move past this line, I'm going to increment a counter called millis. This is something I liberated from the Arduino Ecosphere. They have a millis function built in that's just very useful. This is why, Chip, I want the getMS function to replace getSex. And then I call the updating the RGB LED and then scanning the TTL inputs. Here's the key with the Propeller. This loop, I know it looks weird that I put this at the top, but this loop here, no matter, as long as I don't run out of code space or run out of code timing, this loop will run once every millisecond. Dead on every single time. So I'm doing that because I want this milliseconds timer. And it turns out even in Spin1 on the P1, you can do an enormous amount of work in 1 millisecond. And so I have this kind of thing in probably 80% of the Propeller programs that I write. Just a background cog doing basic management stuff of IO. In this particular case, I don't want to have to be bothered reading the shift registers when the user wants an input. Every millisecond, I'm doing this code. Now this is unrolled so that it's really fast. But every millisecond, I know what the inputs are. And for the kinds of things that this is doing, it works perfectly. And also doing things. But this is the key to timing right here. This is, I'm making a very big deal out of it. It seems like nothing, but it is a big deal. Doing this in a traditional processor is really, really hard, especially in an interpreted language. And it's my favorite thing about the Propeller. And I have with the people that I work with, there is an awful lot of timing-based things. I work in the movie business. It's either 24 frames a second or 30 frames a second if we're doing video stuff. We need that precision. It's very, very easy to do with the Propeller. Sorry if I get a little bit evangelical about that. I really like the timing stuff. Okay, and then remember, I did talk about syntax. In the register is called count in the Propeller 1, and we use wait count. In the P2, there's a function called getCT and waitCT. They do the same things. The reason for this is there's not more than one counter, right, Chip? But there are ways to work with different values. Okay. No, I did that. I think this is the last big topic, so I know I'm running over time, and I apologize to everybody, and thank you for hanging in. Within the P2, there is this bit of magic circuitry in each pin that makes them smart. Now, in fact, John and Chip did a big presentation last week on smart pin modes. that information is available. But, you know, I wanted to share this here for spin programmers like me because Chip made it really easy to do what you need to do with smart pins. Now, some of the smart pins take a little bit of effort to set up, but you know, a lot of us are writing objects, so that will be kind of compartmentalized and you won't have to worry about the gory details that I'm about to show you. But within Spin2, there's pin start, write pin, WX pin, and WY pin that lets you do all the details of a smart pin, just like John showed in assembly last week. And, oh, so let me go back to my editor and show you. Can you see my editor?
Got it.
Okay. I forgot to put this in the thing. I want to point out something that I also like about the P2, even though I initially, admittedly, didn't like the implementation. Now I'm fine with it. Whenever in Spin2, you want to deal with a pin, you can actually deal with a group of contiguous pins. So long as that group is within the same block of the A group, which is pin 0 to 31, or the B group, which is 32 to 63. And the way that you do that is by this operator here called add pins. You can actually manually do this with a little bit of shifting, but it just makes it really easy. And I'll show this here. So I'm going to tell the propeller to run this pin demo. So I wrote this little pin demo that's just running one pin. So I have a pin up here called P0, or pin 0 rather, that is output 24 on the P2. And it's going to turn it on for 10 milliseconds and turn it off for 40 milliseconds. So if I press F10 to run it, oh, sorry. It was, I had my, let me do this. I had this thing. It was expecting me to open my terminal and do that. Okay. So what I want to do now is show you. So this code is running here. This really simple little loop is running, turning a pin on and off. And I'll show you that by going over to my, you should be seeing my oscilloscope now. So this top line and is running 10 milliseconds on, 40 milliseconds off. So if I go back to the editor and we'll do another version of that. So this one takes a low pin and a high pin that defines a group. And I also added those same timing things in there. And here is the code for that. Now, what I'm doing is I'm taking this variable called group and I'm using add pins to create that. So you start with your base pin, which is going to be the lowest pin number, the LSB, and then it's telling how many more pins do you want to add on. So if you wanted 8 contiguous pins, you would do the base pin, add pin 7. That will give you a group of 8, okay? So in this case, all I have to do is subtract that from that rather, and that'll give me that number. And now this is running. And so if I go to the oscilloscope again, now you can see channel B has that other one. So it's an important thing. There was, again, in the slow motion train wreck that I'm following in the forums after the guy was really nasty to me through email, he's having trouble synchronizing signals. And I'm shaking my head and said, if you just crack open the manual and use this add pins, you'd be good to go. It will take care of that for you when you're using smart pins. And so I'll show you that. Nope. You can't see my editor now, can you?
We see the scope.
Okay.
Now we're back at the editor.
It should be back to the editor. Okay. So here we get into the smart pins. One of the this was always kind of a bugaboo with the P1. Because, you know, again, you've seen some of the stuff that I do, lots of LEDs, lots of lighting stuff. So PWM is really important to the work that I do in Hollywood. And so I have a multi-channel PWM driver that I use in lots of projects. Now I don't even have to worry too much about that because the smart pins will do that for me. Now, the smart pins require a little bit of setup, and I will encourage those who weren't on the stream last week to go back and look at the presentation that John Titus and Chip did. But with smart pins, generically, you're going to take a pin or a pin group, you're going to give them a mode, and it has an X and a Y register for configuration that will be, you know, each mode will, the X and Y values are dependent on the mode. So John showed how to do that in assembly. Here's how we can do that in Spin. So with PWM, there are also constants built into Peanut and therefore Propeller Tool that will define those things. So in this case, I want to do PWM on 2 different pins, at least the configuration part. So I'm doing my, you know, my group thing here. Now, in the PWM mode, you need to know how many ticks are in one of your units, which you'll define. Now, again, working in Hollywood, we do lots of stuff with DMX. DMX uses byte values, so 255 represents 100%. So what this will do is this will break down the ticks in 1 kilohertz. So I'm manually defining things here. So I've got a 1 kilohertz frequency and I've got 255 units. Now this has to fit into 16 bits. So this is a thing for the advanced programmers. If you're running really fast, you may have trouble with really slow PWM frequencies and look, you know, might have to look at another mode. So just be mindful of that your setup value has to fit into 16 bits. So that's in the lower word of X. In the upper word of X is how many units in 100%. So this becomes very easy. And now I can use pin start. So here's what's really neat. This is now starting whatever pins I've passed here as PWM outputs. And it's starting off. The Y value would be the duty cycle at start. I'm starting with them off. So now, after this line, I have 2 PWM smart pins if I pass it 2 pins, and I'll show you that by running it. And let me set up the scope. So there we go. And so here in this case now, you know, it's tricky to go back and forth, but I have them going opposite values. So I'm running a loop that's going 0 to 255 that this one is going through. And then in this one, I'm taking 255 minus whatever this value is. So I'm getting them opposite. But you'll notice that the leading edge is aligned in here. Now, in some cases, people don't like to do that. So there is another mode in PWM. Now, I'm using sawtooth mode for this. There is a triangle mode that will allow you to offset. It's a little tricky to explain without having a lot of graphics, but for motor controllers, some people prefer that. Now, you have to, when you're doing your setup, you have to know if you're using triangle mode and you have to change your X configuration a little bit. I have a thing called, I think it's called JM Easy PWM that's online already. And that will take care of that stuff for you. If you look through that code, it will, you tell it what pin, what your range is, and if you want it triangle or sawtooth, and it will sort it out for you. And then you just write values to it, easy peasy. I brought the code out for this demo so you could see what's going on with smart pins. And I'll just do one thing because I know I'm way over time on smart pins. Now, Ken and I love robots. And a really nice thing about the P2 is with smart pins is that we can do a version. Can everybody see my editor? I did share that?
Yep.
Okay. We can turn any pin or group of pins into servo outputs. It's just PWM. It works out really nicely because we tend to command servos in microsecond units. So we can put, I have a constant for 1 microsecond in my program that goes here. And then my window, the width of my window is 20,000 microseconds, which is 20 milliseconds. That's how often we want to refresh servos. And so again, I'm starting the group. I'm doing the same kind of configuration here. And in this case, I'm presetting the servos to the center position of 1500. So when this line runs, whatever pins I passed here will start acting like single pin servo controllers. Now, so they're running and I don't have to do anything to them. If I want to move them, then I have to use the Y pin, because that's the value that holds the PWM duty cycle. I can write that either to the group. I'm doing the group here. I'm doing the same thing and write that value. But if I was building a robot, then I would just write to the individual pin number. So for example, I could, if I change that to pin low, then it would just address that one. So here I'll get this running and adjust it on the scope.
And I have a question, John.
Yep.
So thinking back to like the really early programming days, you're trying to make multiple pulses go at different times. Like if you envision now, whether it's a CNC machine and you have steppers that you're blending and they're all going at different speeds, different directions, or something like, you know, a hexapod robot, 3 degrees of freedom per leg. I see that we can generate the signals any way we want, but does like spin coding now make it easier to do this in a way that you could, you know, wait before you start another and blend it by combining weight count? Like I see it's possible, the signals are all possible, but I'm just wondering about, and you can answer yes or no, since it's probably relates to all kinds of stuff, but.
The answer is yes. You wouldn't do it in a bulk group the way that I just did. What the smart pins allow, and I might ask for an assist here, Chip, is that you can put an offset into them to kind of pre-start them so that you could create a cascade effect. In my P1 servo controller, which gets used a lot, I only run one servo at a time. I output a pulse. So here, for those that, you know, this is the servo pulse. Here's the next pulse 20 milliseconds later. In my servo driver for the P1, I run the first channel pulse, 2.5 milliseconds later, I run the next 2.5 milliseconds. So I do a stair step approach. So only one servo is ever activated at a time. Technically, you could do the same thing in the P2. You would just have to offset when you start the things. But once you've done that, then they're offset and you don't have to worry. So you could do it pretty easily. It'd just take a loop instead of doing a bulk group startup. You do the group so you can see these are aligned because I started them at the same time.
Thanks.
So yes, and like I said, with there's only those 4 commands. It's you know, you can do anything that can be done with smart pins. You can do. So for example, the object that you talked about earlier, full duplex serial that I put up, it uses smart pins for transmit and receive. Now, anybody downloading that object will say, "Hey, what the heck, JonnyMac? There's an assembly cog running too." What the smart pins handle the UART data going in and out, but they only have a 1 byte buffer for each. So the background, all it does is say, "Hey, do you have a byte for me?" "Yes, you do. I'm going to stick it into the user's buffer." Or, "Hey, the user wants to transmit something. Let me put it into the transmit pin." So it's just a UART manager. And I've actually architected that so that it will be really easy to add in a whole bunch of ports. And all the background is doing saying, "Hey, do you have something? Yes, here you go." Or, "Do you need something? Yes, here you go." And it'd be very easy. That could actually, it could probably be done in Spin, but I didn't want to take a chance because I know that I'm already building a 4-port version for a customer. And so I did it in assembly because anybody, if you haven't worked with assembly, the Propeller is the best place to start, I think, because the assembly is sensible. I mean, when you have a programmer of Chip's experience creating an assembly language, you're going to get good stuff because he's been through all the nonsense of all the other manufacturers, and why would he do that to himself? So we benefit from that. You know, and interestingly, I mean, there's a lot to P2. I think in the P1, and correct me with the numbers, Chip, there's about 65 or 70 assembly language instructions in the P1. In the P2, that jumps to about 350. But you'll find lots of groupings and very sensible, easy things to do. I mean, the P2 assembly, there's a lot of stuff that I'll probably never understand, and that's fine. The stuff that I do, I'm giggling about like a kid because it's really efficient, it works really well, and it's very easy to code. In fact, I'm going to talk about that in a second. Sorry, Chip, it looks like you wanted to jump in. I didn't mean to cut you off.
No, your numbers are about right.
Okay.
I think there's about 5 times as many instructions.
Yeah, but they're you know, oftentimes you have a single instruction in the P2 will replace 2 or 3 or sometimes even more instructions in the P1.
Right, yeah. You know, I've looked at other processors of late, and it seems that their entire assembly languages have become inhuman. I mean, they have these cryptic mnemonics that you can't make any sense of. I mean, it's really only the domain anymore of compiler writers. You know, they're going to forever bury those details. But our assembly language was designed to actually be usable by people.
There you go.
You know, who are thinking in terms of implementation and trying to be efficient.
Yeah. So on that, I think this is my final slide. So again, thanks everybody for hanging in. This could be my absolute favorite feature of the P2. In the P1, going back to that, if you want to run assembly code, you have to start a cog, launch the assembly cog, the code into that cog, and then deal with the mechanisms for talking to it. In the P2, you can stick a bit of assembly code into a spin method and it will work just great. And I love this feature. The compiler writers don't like this feature, but I'm not using a compiler, so that's fine. So be wary of this. If you're going to compile your spin stuff, you'll want to talk to the guys writing spin compilers, because they're doing lots of really magical things with their compiler, and this could conflict with it. But if you're not, like me, just using the spin interpreter, you can do that. So the reason we want to do this is because now we get assembly speed without the penalty of having to launch and deal with an assembly cog. And it's really great. So these are things that I have actually done. So we talk about, you know, smart pixels. I probably have some somewhere. You know, these things, you know, we're all, oh, this green screen thing's kicking me in the teeth. You know, you know what I'm talking about. There are times though, like, you know, if I look across the room, there's a bunch of trade show badges. And oftentimes people are now putting smart LEDs on those trade show badges. Well, why would you have to use a whole cog to run 4 LEDs? It just doesn't make any sense. So if you don't need all the features of my driver, which is out there for the P1 and the P2, you can just do a really simple thing. So let me go over here and there it is. So here is a little object that I wrote called WS2812EZ, which has just a few of the features. And you start it by, the start method just gets the clock frequency stuff, because this is timing based. The single wire LEDs have very precise timing requirements. And so this sorts all of that out. And now here, this method, now that you have the timing, this method will handle, I'm going to make this a little smaller so we can get it all on one screen. This will take care of taking this number of LEDs that are in an array that is at this location. Here's that exception where I say P_colors. That's a pointer to the array of longs that is holding my colors, and it'll transmit that data out this pin. So I'm not going to bore everybody with the assembly code. This, you know, is a little, this is simple stuff. I mean, I'm an actor. I write simple code. But this does the WS2812 stuff and then jumps back and you're there. So you don't have to have a full cog running all the time to manage a couple of LEDs. This is wonderful. It also is a great learning tool. I do this a lot, and this is the thing I'm going to encourage. You notice up here, I have this program called Experiments. So this is a file that I have that I save all the time. In fact, Chip, I had a question because, again, that slow motion train wreck in the forum, somebody was they were making assumptions about operators. And I asked Chip, I said, hey, we can use these things to do power and roots and that. And so we were having a conversation and I was doing experiments with this. So like, if you want to raise X to the power of Y, here's how you do it in Spin. Chip, thank you for helping me with that. And we'll have to get it out there because this will be useful. If you want to take the square root, do that, or a root, you can do that. Now,
yeah, and hey, one thing, John, it might be good to point out that the reason we have this QEXP, which is an exponential, and QLog for log. The reason we have those is because they're actually in the hardware in the assembly language.
Right.
And
Yep.
so it's nice to be able to, do things by using logs and exponents. It's a real shortcut around some complexities.
Here's a really interesting thing that I told Chip on that day. So one of the things that I do all the time, I joke with friends and clients that I'm always chasing microseconds. So remember I was talking about the system counter. I will stylistically do things based on how fast stuff runs. And I can prove how fast stuff runs with a little bit of test code like this. So if you look at this, T is grabbing the system counter right here. I'm going to insert some test code there, and then I'm going to grab the system counter again, subtract the original variable, and then also subtract 40, which is the number of ticks these two things take to execute. So if I ran this right now, I'd get 0. So I've got an empty loop. Now I can insert a bit of code and it will tell me how long it took to run. When we were playing this, this was my first attempt, was this bit of assembly code. And then there was this one where I think I unrolled it or did some things based on what Chip said. Chip said, no, do it really simply. Just do it in pure spin. The interesting thing that I was a little bit taken aback by is that this pure spin code runs faster than the assembly code. Now remember, this is inline assembly, so it has to be shuttled over and that. But this really simple line of code ran fastest. And I was able to determine that using the propeller. And this is, again, a very, very unique thing when you're doing critical timing stuff, which I sometimes do. I imagine others do. The propeller can tell you. And one of the things that I want to encourage newcomers especially is to give yourself time to play. You'll notice that here in my experiment, I'm just using the terminal as output. I'm writing bits of code. I'm using, internal stuff to figure out the timing, and then I'm outputting the results. I spend a lot of time doing this. So then when it comes down to writing actual application code, I don't have to figure that stuff out. And if you're a new programmer, no matter what the language, give yourself time to play. Give yourself permission to play. Because when you have to do the work, you'll wish you played, so that you don't have, you're not sweating a deadline. You have those things. And so I do this all the time. It's why this program lives. And you can see these were the last experiments that I did. But doing this, fantastic. I have P1 and P2 versions. I do this all the time to figure out how to write a snippet of code so it will run even faster. Okay, last little thing. If you're new, the forums are a great place. They can occasionally become the Wild West. I've been on both sides of that. So please and thank you will get you a very, very long way, especially with cranky people like me. When you're asking for help, be specific. The root word of specification is specific. Somebody the other day said, oh, just show me some simple code. I don't know what simple means to you. Tell me, you show me what you think is simple, and then I'll show you how to do that in the Propeller. If somebody like, well, I'll take myself out of the group, but if Peter Jakacki or Ray Roddick or Phil Pilgrim or Mike Green or any of the forum regulars, if they tell you to do something, just do it and then debate them. There is a guy who I think lives here in Los Angeles that has a project that's been going on for 6 or 7 years that they're just, oh my goodness. Bunches of us have sent the guy working code and he's still, it's insane. And it doesn't matter if you're building a blinky light or some anti-Klingon death ray to protect yourself from the aliens that have taken over the government. Just be specific about what you need and take the direction. And try any code that somebody sends you. I've had people say, well, I looked at your code, I don't think it'll work. I don't have a habit of sending code that's not tested. Just try the code. I almost said a bad word. Now this is getting, my mentor who's in heaven now, Cliff Osmond, he used to say that we often give advice we need to hear. This is one of those things for me. Have you considered generally sits better with people than you should do this. I hate when people say, Johnny Mac, you should do this. Johnny Mac, you should do that. I so, nah, I'm not listening to you. I will, don't tell me what I should and shouldn't do, but make suggestions and I'll take them. So try that. There is a couple of things. These are, I know I'm being a little jokey, but these are serious because I recently went through this. I had a member contact me offline. I mean, I make contact easy in my emails and all of my stuff, but then he became abusive, was actually very harsh to me offline. And I said, hey, I'm a consultant. I'm about to start billing you. Take it to the forums if you want my time for free. And this is an important thing. I know this sounds harsh, but nobody owes you anything, If you ask a question in the forums, it will probably get answered. People are fantastic. I've made friends with people because of the forums, but nobody owes you anything. So be kind, be courteous, be a team player. And this is the best way to learn. There's plenty of people in the forums that will let you do their work for them. Go find that. There's no stress on you. Go read through and say, oh, this person needs to figure out that. I don't know how to do that. Let me figure it out. Give them the answer. You get the exercise that they should have let themselves have. They get the answer. Everybody wins. But you can do non-stress work by doing things, by helping others. You help people, and hopefully that will encourage other people to start helping those. Before I get off again, Spin is my favorite language. It's all I use for the Propeller. Although I've worked with all of these things too. Ken has done a masterful job with the education world and Blockly, getting lots of kids involved. Back in the old days, Ken and I, when I was working for Ken, did spend a lot of time traveling around teaching kids. Love that. Kids are open. They want to do things. We have real opportunities there. There's a couple of basic compilers. Terry Hitt who did SXB. That I worked with him on that. He converted that to Prop Basic for the P1, and Eric Smith has his Flex Basic that works on the P1 and P2. If you're a C programmer, and I know lots of you are, there's Catalina and Flex C. There is Forth, which I have every Forth book ever published, and someday I'm going to master this, and then I'm gonna call my friend Peter Jakacki and say, finally, I figured it out. It's a neat language, and what I didn't put on here, it's built into the P2. So if Tacos, I think that's how everybody's pronouncing it, is a version of Forth that is built into the P2. This has made a lot of my friends in the movie industry really excited, because a lot of people in the movie industry are doing camera and motion control stuff, and Forth is very popular for that. And finally, MicroPython, also very popular now. I just helped a friend of mine, those of you that are into the cosplay world, or if you are, my friend Svetlana Quint, who is professionally known as Kamui Cosplay, she needed some help with MicroPython the other day. So I told her, hey, the Propeller can now do MicroPython. Trying to get her to switch from the Arduino to the Propeller because when it'll be easier to write code for her, because I can write her Arduino code, but it's not as easy. And a couple of things for the newcomers. 80% of the time, you're only going to use 20% of a product's features. So don't get panicked when I say, hey, there's 350 assembly instructions. You're never going to use all that stuff. And somebody will, but you don't have to. This is a really great, but the 20% that you need, just get really good at it. And this is a big thing. This was a lesson from Toro, a company I worked for when I was a young guy. Spend 80% of your time thinking about your project and 20% of your time implementing. You'll be happy you did. Most of us, it's human nature. We want to rush in and do something. And then we do it again, and we do it again, and do it again. This is how schedules get extended. Spend your time thinking. When Rick and I did the little controller for the Thunder project, we talked about it for a couple of hours before we did anything else, because we wanted to make sure we were all in agreement what we were going to do, because we only had one chance to do it, and we succeeded, and everybody was very happy about that. Finally, I'm going to leave you again, my mentor, everyone. Cliff Osmond meant more to me than any other human being, and he used to always say this to actors: simplicity is elegance. Always, always, always strive to be elegant. So anyway, I'm sorry I took so long for my presentation. Thank you all.
That was great,
That was-
John.
Yeah, that was excellent. You know, it's really good that you kind of covered the lay of the land and how to think about things, because I think anybody, when I go to look up something new, it's hard for me to get a handle on what the overall shape of it is and how I work it. But what you did is you explained how the propeller works, and that's just fundamental stuff that people need to know in order to approach it. It's really not hard at all, but there needs to be some definition of what it is.
Yeah.
And your 80-20 rules are right on.
Yeah, again, not mine. I've been blessed in my life with really good mentors. And this is one of those things that stuck. And so I tried to share it with my mentees. I hope a couple of them are online. I can't see everybody is online, but I know my friend Ryan from the cyber world was online earlier. So, you know, we used to talk about that all the time. So probably nobody wants to ask questions, but I'll take them if they do.
I'm still here, John.
Man, we've had enough of that guy.
So questions are welcome for John.
Yes. Yes.
Hey, John, this is Dennis. Hey, I asked you probably kind of offline. You did this thing a while back, HDCP.
Yes. Yeah.
I love that thing. I use it all the time, and I see a lot of guys on here. They're trying to pass numeric data through a UART or through serial anyway, and they get all confused with trying to send numeric data. And I found with HDCP, it just sends the text, and it gets broken down in these fields, and it's been fantastic. So I've got it running kind of on my Spin2 when I upgraded one of my robot programs, but. Make sure you put that on Git as well. It's really handy, and it does such a fantastic job of sending, basically text that you can look at with a debugger or whatever, or just print statements. But at the same time, you can get numeric values and all. It's really, really handy.
Thank you, Dennis. What Dennis is talking about is called HFCP. It stands for Human Friendly Control Protocol. And I had done this based on again, somebody I was very blessed to know in Dallas when I belonged to the Dallas Personal Robotics Group. There was a guy there whose company monitored well sites around Texas. And he was showing me his lab one day, and I saw a bunch of these text things going along. And I said, "What's that?" And he said, "Oh, these are wellheads talking to my system, and I'm talking to wellhead." And it was all in human readable text. And I said, "Wow, that's kind of interesting. You don't want to put that in a digital packet?" And he said, "I could, but it's not a lot of data. And by doing it this way, I can throw a terminal anywhere in the system and I can see what's going on. And I can even, in some cases, access in." So the HFCP, I did as a presentation in Nuts and Bolts. So I actually played with it the other day, Dennis, after you mentioned that. And I will tidy it up. Now, since I brought up the Octal thing, I want to add that because Octal is not one of the formats that's supported yet in HFCP.
Right.
And but to everybody else, and so this doesn't become a private conversation between me and Dennis, it's a text-based way of sending information, and I'm using simple comma delimited fields. So, a message going from the master to a unit starts with a greater than sign. That means it's going out. And then the next field is the slave ID, which is just a number. And then the comma after that is a command. And things after that become, variable. You can define them, but you can send numbers and strings and that, and it becomes very easy. I've used it in a couple of client projects, and it becomes nice and, again, easy because you can read it without having to decode it. That's why I call it human-friendly control protocol, even if that is a very arrogant name to give it.
Well, thanks for doing it. And I see so many people with, postings about, they're passing this data around. I used XBs, I guess, is when I was using it.
Yep.
But this is something they need, especially for us beginners or us newbies or guys that don't have a lot of tech and don't have maybe a scope handy. It's just the easiest way of watching your communication. So
Yep.
I hope people will, get to see that and start to use it, because it'd probably get rid of a lot of long conversations that I've seen lately on the forum.
Well, this is one of those specific things, because this just came up the other day. Somebody said, "Hey, how do I send this hex value between point A and B?" And, then the specificity becomes, wait, are you trying to send a single byte that you want to define as hex? Or are you trying to send a hex string of that byte those are things, and newcomers don't often understand that because they see definitions. This is why I kind of just hammered it. And I know I spent a lot of time on the numbers thing, but as a reminder, number formats, whether it's binary or quaternary or octal or hexadecimal or decimal, those are for humans. Inside the computer, it's all binary anyway. The other formats are for us. And so once you wrap your head around that and say, oh, okay, so if somebody gives you a specification and they're showing sending values as hex, you understand, well, that hex value translates to this and you send it. But you need to know in that case, okay, am I sending a byte or am I sending a hex string? Those are the specificity things that sometimes trap us in the forms.
All right. Thank you.
Yes, sir.
Hey, John. Maybe I missed it when you were talking about PWM for motor control. But in case, well, for the benefit of everybody, I think I know what the answer is, but why would you offset the start of the signal for each motor?
Well, when you have the high going pulse, remember you're sending energy into an inductor, and there will be an inductive surge. And so, now I'm not a motor control guy, although I've done motor control software for simple stuff. So some have suggested that if you can offset those starting edges, you can create less, inductive energy at the same point in time. So, it's like stacking them up. If you've got these two energy pulses, if you start them at the same time, you've kind of got this stack up of energy. I hope that makes sense. And now this only works though is when, if you have the two, say you have two PWM channels, if they're running the same PWM frequency, using the triangle mode will give you that offset as long as they have a different duty cycle. If they have the same duty cycle, their edges are going to match. But it's not always, you're more often than not, you're going to have a different duty cycle. So the edges will not be matched, and therefore you have less noise. That's my understanding. So again, when you're using the triangle mode, you have to, since the way the internal counters work, it's doing double duty. You have to actually change your X setup value. But my object, my easy PWM object, takes care of that for you. If you say triangle mode, it will adjust the counts. So you get the same frequency that you asked for. And you'll just get, internally it's using a different mode.
John, a question about that. Is it possible to think of that in terms of, and I truthfully don't know, I'm asking, in terms of simultaneous power draw on your power supplies? And so by offsetting them, you're drawing less instantaneously?
Yeah, technically you are, because you remember whenever you send current into an inductor, there's going to be a surge current as the inductor. And now I'm not a scientist, I don't know how to explain that process, but you're minimizing that from the power supply. Now, I'm a very conservative designer. Anytime I design power stuff, I'll figure out what I need and tend to triple it so that I don't have those issues. But in the case with any electromagnetic thing, you're going to have radiated noise. My understanding is the reason for offsetting those leading edges on the motor control pulses is to minimize that too.
Nice.
Yes. I'm scrolling through the viewers and I see my friend who is a stormtrooper on the other side of her life. And learning, she has a propeller. And she's heard me talk. She's heard all of these things from me a dozen times.
And I'm going to stop the recording and get that ready for YouTube. So anything else people want to chat about, we can carry on. Thanks, John.